Okay, so thank you all for having me. I really appreciate the chance to come chat with you all about JWTs. So let's jump in. So real quick, this is not pitchware by any means, but I do want to mention my employer since I'm doing it on their time. We are a drop-in user data store, something like Okta or Auth0, and we have multiple different levels. We have paid editions that you can buy support from us and premium features such as like LDAP integration. We also have a community edition, which is free as in beer, and you can run that anywhere you want. It supports multiple different OAuth grants, SAML, passwordless authentication, and a whole lot more. And how that's relevant to this conversation is that it produces a lot of JWTs. So about me, who cares? Y'all didn't come here to learn anything about Dan Moore. You came here to learn about JSON Web Tokens. If you have questions, please just unmute yourself and ask, or you can definitely put them in the chat. Those will probably, the ones in the chat, I'll probably wait to the end to deal with, to answer, not deal with. And if I lag, please let me know. So JWTs are JSON Web Tokens, and they are an IETF standard, good old 7519, and they are stateless portable tokens of identity. And what that means is that you can know that this JWT represents some entity, and you can know who created it without ever talking to the creator. That means they're great for APIs because you can have an identity provider, such as FusionAuth, generate a JWT, hand it to a client, and have that client present it to multiple different APIs. And those APIs can know what level of authorization, what level of permissions the sender should have without ever talking to the user API, or without ever talking to the identity provider, excuse me. So they are bearer tokens. You can have JWTs that are tied to particular clients, but more typically they're just used as like a valet key, right? Like when you hand or a hotel key might be a better analogy. The hotel key doesn't care who you are. As long as you hold it, it's going to let you into that room. So that's what JWTs typically are. So let's kind of walk through a scenario, right? And think about why we might want to use JSON Web Tokens. So here is a typical service-oriented architecture where you have an API that is responsible for handling users, right? So that's create, update, delete of users. And then you have a API that's responsible for handling to-dos. So this is the canonical to-do app. And we are going to, in this user API, store user information, probably roles that they have, because you might have a premium level of your to-do app or something like that. And our to-do API is going to store to-dos, or it's going to have a data store that stores to-dos. And so we're going to be interfacing, our clients are going to be interfacing with both of these APIs. And the to-do data store might be a typical relational database. It might look a little bit something like this. And the real question is, what does this user ID look like? How do we tie the to-dos for our application to the users when they're not, you can't use a foreign key or anything like that because they're totally separate, distinct, disjoint data stores. So let's kind of walk through what might normally happen, right? I am a client. I will authenticate with the user API. You present username and password or some other kind of credential, and the user API will go to my data store and say, okay, who is this user? Is this really Dan? Okay, it is Dan. And we'll send back JSON representing me. And that JSON might look a little bit something like this, has information about my ID, my name, roles that I might have. And that client then extracts some information from that JSON, passes it to the to-do API, and gets back to-dos. Now, obviously, this is a very naive implementation. Please don't ever implement like this because there's a real big problem. The problem is that a malicious client might notice that it passed user ID equals 42 to the to-do API and got back user ID 42s or user 42s to-dos. And they might say, well, wait a second, what happens if I pass 1 or 2 or 3? can I see other people's to-dos? Which obviously we don't want to have that happen, because the fact that I'm going to go get milk after work today, that needs to remain private to me. Thank you very much. So what can you do? Well, a less naive implementation is actually just to create an opaque token. And so in that case, the user API is going to just create like a string, can be alphanumeric, doesn't really matter what it is. Pass that string as part of the user object to the client. The client then will present that token to the ToDo API, which the ToDo API doesn't actually know what is in that string, so it needs to figure that out too. And so it needs to talk to the user API. And so that's beneficial because the malicious client can no longer iterate on that token. I mean, I guess they could, depending on how big the token is, they could keep trying different tokens, but it's very unlikely they would hit anything if it was a large string. You can't iterate the same way you could an integer. So that's the major benefit of this. The detriments are that it puts more on the user API. It has to kind of maintain that user token mapping and maintain that state. And the biggest detriment to me is that it couples the user API to almost everything. So anytime you want to pass user information, or you want to get user information in a dependent API, like the ToDo API is, that dependent API needs to take that token and pass it to the user API and get that back. Now, obviously, you can add in caches or other things to kind of reduce some of that load, but do you really want your user API to be coupled to everything? And if the user API goes down, the ToDo API suddenly can't look up the user's to-dos. It seems like a bad idea. So JWTs come into the rescue here. So what happens here is the user API, instead of creating a token, they create and sign a JSON Web Token and pass that to the client. The client then passes that to the ToDo API. And that ToDo API now can validate that two things. One, it can validate that the user API actually created this JWT because it's been signed by the user API. And we'll talk a little bit more about that mechanism in a bit. And the second thing it can do is get extract a bunch of user information from that JWT, knowing that it hasn't been changed over the wire. And so therefore it doesn't have to actually call into the user API to get that JSON like the opaque token scenario required. As I mentioned, it can
quick question, Dan.
Of course.
Was just, if you go back, so that it sounds like the ToDo API would only ever work with, as long as the JWT was like valid and I guess associated to the right user. Is that how it works?
So the JWT looks like it's a JSON object. So it has user information in it, yes.
Oh, okay. So the ToDo API would never, well, now it doesn't have to touch a user API to be like, hey, which user is it? But it just, there's enough information in the JWT for the ToDo API to do its job.
Exactly. Yep. So that means that you don't have any kind of communication between the two. Yes. And we'll see what JWTs look like in a couple slides. So, does that answer your question?
Yes.
Great. Cool. Yeah. So as I mentioned, the ToDo API can know certain information about the user without ever talking to the user API. It is signed, and there's two different ways to sign a JWT. You can do it via a symmetric key, or you can use a public-private key pair, and we'll talk more about like why you might choose between those. Some of the examples early in the talk are going to be symmetric key pairs, and then we'll talk more about public-private later, or symmetric keys, sorry. And the other kind of big win with JWTs, bigger than or that differentiate them from that opaque token again, is that you can put whatever you want in there. Now you probably shouldn't put too much in there, because it's well, I'll talk about that later too, but you can put whatever you want. So if you have a business particular a particular business domain attribute that you really need passed around to your APIs, premium level, or has military clearance, or whatever it is, you can put that into your JWT, and then your APIs can then get that out. So enough kind of diagrams and stuff. Let's actually look at a JWT. So this is a JSON Web Token. There's 3 clauses, 3 parts to every JSON Web Token. There's a header, which has metadata about the JWT. There's a payload, which has the actual information about the JWT. And then there's the signature. And these are all base64 encoded. And the reason for that is that that makes it really nice to put into headers, like an authorization header or something else, any place that might choke on, normal curly braces that are a key part of JSON. But you could cut and paste this, and I'll make this presentation available into any number of online tools, and you'll see or cut and paste each of the clauses, and you'll see the actual plain text. So it's not encrypted. I guess that's worth emphasizing. JWTs are signed, they're not encrypted. So no secrets, basically. So a JWT header looks like this. And in this case, all we are saying is which algorithm was used to sign this JWT. You can put other things in the metadata, but that's all that's in this one. And then here's the payload. And this is kind of where all the action is. This is the fun part. And so like some other parts of computer science, authentication people like jargon. And so each of the keys of this JSON object are called claims, which basically mean that they are stating something about the entity to which this JWT refers. And some of these claims are standardized and some of them are not. And you can add your own claims if you want. So I'm going to kind of walk through each of these claims. ISS is the issuer. So that is some reference to the user API in the scenario I walked through before, or an identity provider, somebody that created this JWT. It's the issuer of the JWT. EXP is the expiration. So that is the timestamp, the time beyond which this JWT should not be considered valid. The odd is the audience. So this is who this JWT was created for. So you could imagine that if we have a ToDo API, we have an email API, we might want to issue different JWTs to the client, and then they can present a JWT that is designed for the ToDo API that maybe has roles or other business information to the ToDo API. And if it was presented to the email API shouldn't really care about that JWT because it wasn't made for it. So that's what the audience is all about. The sub claim is the subject of the JWT. So that is the entity to which this JWT was made for. The entity that this JWT represents. So in that case, it might be, Dan or Dimitri. But again, you want it to be an ID so that you can kind of reference back to things. And then there's some other claims here, but those are not standardized. And then you have a signature. And these can be, as I mentioned earlier, it can be RSA or elliptical curve cryptography or HMAC, which is a symmetric algorithm. You have a variety of different options there. And, the main differentiator between them is if you're talking about symmetric versus asymmetric, that's obviously a huge differentiator. Then it turns into like a question of like, what's the right performance fit for you? Finally, at the end of the day, we get to this a statement that we might run against the to-do store, right? We've looked at the JWT as the ToDo API. We've looked at the JWT. We've verified that it's for us, right? It has the right audience claim. We've verified that the issuer is something that we expect, and we can now pull the subject claim out of there and get the to-dos for our end user. So that kind of is the evolution of JWTs, right? It's a way for you to solve a distributed identity problem in a service-oriented or microservices architecture. So it's a good time to pause and see whether you all have any questions about that. And then we can talk about some other aspects of JWTs in the next section.
Is the client able to read what's in the JWT?
So Josh asked, is the client able to read what's in the JWT? Yes. So if they have any, they cannot modify it. So that's a big win. Because if they modify it, the signature becomes invalid, but they can absolutely look at the JSON structure.
Yeah, I don't have a question, but I was actually just sending Josh some messages. So I'm a fairly young CTO, and one of my interesting stories was someone had implemented a JWT solution when really they intended to and needed to implement like an encryption solution where the information is not simply readable anymore. The goal is to make it unreadable unless you have the private key and etc. And this I'll just mention out loud, like I've worked with JWTs for at least 6 years before that, and yet it still had sort of like slipped through mine like everyone else's review process. So I just want to reemphasize, like, don't put secrets into it. It is a method of signing. So I love, Dan, that you've highlighted that.
Yep. I will say, and you know, I used to be a consultant, so the answer is there's always like gray area. There are ways you can sign JWTs, or sorry, there are ways you can encrypt JWTs, but it's not the typical usage I've seen. They're much more commonly signed, and you have to take certain steps to encrypt them. But I always say that it's better. I mean, you should send JWTs over TLS, right? Like everything should be over TLS. Don't look at my private website. I haven't put it on TLS yet, but even then, you know, if you send a JWT down and it gets stored as a cookie and a JavaScript client can look at that, right? Or any other piece of JavaScript running in that person's browser, unless it's an HTTP only cookie, can pick up that access token or that JWT and again, look at it, right? So it might as well be on a postcard that anyone can look at. They just can't change it. So thanks for sharing that story, Dimitri. Any other questions right now? Awesome. Oh, go ahead.
Thanks so much, Tom. In terms of like the expiration, right? Like a user information changes, credential change, or you know, you block the user or something like that. Is that true that like the JWT will still, like the token will still be active until it expires? Is there any way to like speed up that validation process? You know what I'm saying? Is that still like case?
Let me repeat back your question and make sure I understand it. So you're saying that, okay, so I have this JWT that's good for an hour and someone logs out. Is that JWT still going to be good for another 60 minutes? Or is there any way I can revoke it?
You know, I block the user, you know, something like that. Like the user is not, you know, valid anymore.
Sure. Yeah. So I appreciate, I should give you a tip because that's actually a separate section of the presentation. I talk about revoking JWTs, and there are some ways to do that. Not super clean, and it's just a trade-off, right? Like you don't get portable state, you don't get statelessness without, you know, having some issues. So I will walk you through a couple of different options further on in the presentation, but good question. And right to the heart of like the trade-off that you make when you pick JWTs as your identity mechanism. Yeah.
That's one thing that always bothered me.
Yeah, totally.
Yeah.
I get it.
It doesn't bother me, but you know, I'm just curious if you had any. Yeah. I'm curious about that part.
It's a trade-off for sure. Cool. Anything else, or should I proceed? Great. Okay. Cool. So JWT, it's a kind of a big specification, and anytime any articles about JWTs show up on Hacker News or Reddit, people come out of the woodwork and say, "Oh, this is horrible. Cryptographers laugh at this specification," you know. And so I'm going to present a couple of things that hopefully you can avoid, or things that you should avoid. So JWTs have lots of configuration options. There's a lot of edge cases that are handled. And so, you know, my first recommendation is always just use a library. There's a ton of open source libraries out there. FusionJWT has one for Java. I'll show you some code later on in the presentation. There's one for Ruby, the JWT gem. So make sure that you use a library rather than kind of decoding any of the JWT stuff yourself, because it'll take care of some basic security measures. Many libraries take care of the expiration piece and the signing piece, so that you pass the key and you pass it the JWT, and it will throw an exception or blow up or not return the JWT if it doesn't the JWT doesn't meet those two things, right? If it's not currently valid, if it doesn't have an expiration time in the future, or if the signature is screwed up. The other thing I would say, again, is to verify those claims, right? And libraries can help you with this, but I haven't run into a library that has a default, like super secure claims verification process, just because some of it's business logic dependent, right? but that includes things like verifying the issuer, verifying the audience. You could even like look at the subject and see whether the subject is who you expect it to be or what the format might be, right? You don't want to just blindly take that subject and not treat it as user input, right? You want to do some cleaning up on that. To Dimitri's point, they can contain arbitrary JSON data, but don't put any secrets in there. The contents are simply base64 encoded. They're not encrypted. And the other kind of level 1 foot gun is make sure that if you're using a symmetric key that you make it very long. Otherwise, if you have the JWT, there's actually a C program out there, an open source C program that can look at the JWT and just try to brute force it. And they will, if the key is small, the brute force program will actually give the key back to you. And I think the example is like 4 characters in the repo, but the principle is there. And then once someone has that key, they can now sign JWTs as you, right? And obviously that's something that you want to avoid if you have any, desire for securing your systems whatsoever. Another JWT foot gun is you definitely want to make sure that you store them carefully when they're used as an access token. And again, this is a very common use case. So what you want to avoid is someone stealing your JWT, right? And that could be a man-in-the-middle attack. It could be looking at pastebin or something like that, and seeing a JWT show up in GitHub. GitHub will now warn you if you commit a JWT, or it could be just a piece of bad JavaScript running on the browser, looking at cookies to see what looks like a JWT and sending them off to a server. Now, again, the risk is small depending on how long your JWTs are valid for, right? Because every JWT has this like built-in safety mechanism of, hey, it's only good for an hour, or it's only good for 5 minutes. But within that time frame, a bad actor could grab a JWT and then pass that to the ToDo API, and oh no, they've got access to all my to-dos. So if you're going to store the token, which we understand you typically have to do, FusionOS recommends that you store it server side if at all possible. And that's just because that's just a more controlled environment. And then use a session to tie it to the tie the client to the JWT. But we recognize that doesn't always work. And so if you are going to send it down to the browser, it's recommended to store it as an HTTP only cookie, which means that you don't have as big an issue with cross-site skipping attacks. And if you're going to store it in a mobile client, use like the iOS keychain, or I think Android has secure storage. So those are recommendations around token storage. A big one, which is just a super easy own goal to avoid, is this none signing algorithm. And so the specification actually allows you to not create a JWT without a signature. And so that might change the JWT from looking like this to looking like this. So again, you still have the 3 clauses. You have the header and you have the payload. The signature is missing, but you still have to have that last full stop. And the header changes from this to this, so the algorithm's none, and the payload doesn't change. But the issue with doing this is that this JWT can be generated by anybody. And so if you, as a consumer of a JWT, accept that, that means that as soon as somebody figures out that your API accepts JWTs that aren't signed, they can send any payload they want at all to your API, and your API doesn't know who created it or whether the contents have been changed in flight or anything. So the specification allows this, and I have listened and done some research and found out, there are reasons why, and because it's an IETF standard and it's big and covers lots of use cases, but the simple fix is just don't ever allow none. So if you ever are examining a JWT and you look at the header and it says algorithm is none, or you don't see a signature, throw up your hands and just don't consume that JWT. Just don't even bother, because you just don't know who it's from. You don't know the provenance of that data. Now, of course, again, back to consulting land, there's always some exceptions, and the exception is if you have some other way to verify that JWT is unchanged, that you know who the client's from. or you know who the client is. So that could be mutual TLS, right? If there's client certificates, or if there's a certificate on both sides of the transaction, you might not care about the JWT because you have other ways of verifying who sent you this. It could also be on a private network, and you know what every client is. So I will say that I don't think that anybody who is in that situation of this is probably attending a intro to JWTs talk at NYC Ruby, but it's possible. And I would just say, don't use the none algorithm unless you know what you're doing. All right, any questions about the none algorithm or any of those other foot guns? Great. Okay, let's talk about public-private key pairs. So the previous examples were all signed with a symmetric key pair, and that's really simple conceptually, but public-private key pairs actually bring some real value to the table. The first thing that they do is they mean that there's no shared secret. The user API and the ToDo API needed to share some key for the user API to sign the JWT and for the ToDo API to verify that the user API had done so, right? To verify that signature. And that works fine if you have a small application. It's easy for you to put a shared secret into an environment variable and share it across, multiple Heroku instances. Works great. If you start to have a bigger organization with different teams working on different pieces, that sharing that secret may be harder, and then it also may be impossible if you're actually working across organizations. If you have one organization that is controlling your user identity provider and you have other organizations that are building consumers of that JWT. The other thing that another benefit that the public-private key pair brings is enhanced security, because if you have that shared secret, if that ToDo API gets compromised in some way, it has access to that shared secret, and it can sign and generate JWTs that are indistinguishable from those that are signed and generated by the user API. So public-private key pairs are good in both those ways. They also make key rotation easier, and they support multiple keys. However, nothing's free, and so public-private key pairs, like all public-private key pair stuff, it's more complicated to do with JWTs. Not tremendously more complicated, but somewhat more. And then it's slower too. How much slower? I did some benchmarks with Ruby a while back, and it was, I don't know, 5 or 6 times slower. I don't think that that's typically going to be the choke point of your application, but maybe it is, and maybe that trade-off is worth making. So how does this actually work? So in this case, the user API would sign a JWT with a private key and then pass that JWT to the client. The client then would pass it to the ToDo API. And now this ToDo API needs the RSA public key, or whatever, the ECC public key, whatever the public key is. And it might have it cached, stored locally from a previous request. If it doesn't, it needs to reach out to the user API and then pull down that public key and then probably cache it or whatnot. And then it can use that public key to verify that this JWT was signed by the user API's private key. Now, you might be saying, Dan, wait, I thought we wanted to decouple the user API from the ToDo API, and you just recoupled them again. And I will say, I will submit that they're not as tightly coupled, right? Because this public key probably isn't changing every time, and you don't need to make this request every single time you get a JWT. So this is what the public key might look like. Again, it's just basically JSON with a normal RSA public key text in there. If you have more than one key, which you may want to, again, this is another way of like segmenting things and doing like, the principle of least privilege. You can segment via audience, but you can also segment via key. And so in that case, you just pass a key ID as part of the JWT header, and then the consuming API, the ToDo API in our use case, we'll just have to find the right public key to verify that signature. So refresh tokens are a key part of any JWT conversation. JWTs are supposed to be short-lived, right? Minutes, maybe an hour. Refresh tokens are long-lived, and refresh tokens are very similar to those opaque tokens that we saw in the second scenario when I was walking you through the ToDo app. But they can be presented to the user API and create new JWTs. And the way I think about refresh tokens is that they're this kind of intermediate step that introduces some more complexity, but it gives you this nice compromise between two scenarios that are pretty horrible. The first scenario is you make a JWT, very, very short-lived, right? A minute, and then every time that JWT expires, you force the user to log in again, which is a horrible user experience. Or you make the JWT long-lived, like, oh, screw it, I'm gonna make it live for a month. And then you have this security risk because even after a user logs out, that JWT is still valid to the point of the person who asked that question earlier. And that obviously is a security issue. So with refresh tokens, you can make JWTs short-lived, but not force the user to log in regularly. So how does this work with the diagram in practice? The user API basically generates a JWT and a refresh token when a user authenticates. They pass both those to the client. The client presents the JWT to the ToDo API as in the previous scenario, and the ToDo API is happily accepting that JWT until 5 minutes have passed or whenever the expiration time, in which case it says, oh no, I can no longer give you Dan's to-dos because this JWT is expired. And maybe it gives me a 403 or something. The client catches that error and says, well, my JWT's expired, but I still have this refresh token. Let's see if I can get a new JWT. Passes the refresh token up to the user API. The user API sees that it's still a valid refresh token and then passes back the JWT to the client. And then the client can now take this new JWT, which has a new expiration time, and pass it to the ToDo API again. So that's basically the flow with refresh tokens. And that's the win that they give you, is that you have this way of extending the lifetime of JWTs without requiring users to authenticate. As far as deleting users, in a normal monolithic Rails application, it might look a little bit something like this, right? Where someone says, hey, screw you, I don't want your app on my phone anymore. I want you to delete my account data. And, depending on where your users are, like if they're in Europe, they take that really seriously, right? You really want to be able to delete all their data. You don't want to just be able to delete just their user data. But in this distributed architecture, you don't have on-delete cascade. So how are you going to deal with that? Well, you have a couple options. Option one is you push complexity to the client and you make the client call delete for each API, and they can pass that user ID to the ToDo API and the email API and any other APIs that might happen. I don't know about you all, but I don't like pushing complexity to the client. I like keeping complexity on the server because I have a lot more control over that. And this might work fine for 2 APIs, but if you have 10 or 20, or you have a client, you roll out a new API that client doesn't know about, there's just additional complexity if you push it to the client. So instead, you can push it all to the server side. In this case, you can have the user API basically be able to fire webhooks. And so any API that is interested in finding out when a user's been deleted can sign up for that, and then they'll get that delete event, and then they can do whatever cleanup makes sense from their side of things. As far as kind of logging out, basically in a JWT-based system, your options are to revoke the refresh token. And that's really about all that you can do. Might look a little bit something like this. Again, we have a user API. The client logs out, they delete the JWT on their side and the refresh token. They call a Logout API, which the user API catches and says, okay, this refresh token is invalid. I'm not going to be able to mint any new JWTs from this refresh token. And again, there's still a JWT floating around, and we'll deal with that again in a couple of slides. But this is kind of what logouts look like. And if you have multiple different refresh tokens, you want to make sure that you revoke all those refresh tokens. So the question asked earlier, can you revoke JWTs? And the answer is sort of. And so you have a couple options if you have a situation where you want a user to be user account to be invalidated, or you want someone's account has been breached, and you want to just make sure that that JWT is no longer valid. So the first option, which is kind of the burn the place down, is rotate your keys. And so if you rotate those keys, then you know that no JWT that's been signed with those keys will be valid anymore. And that could be a good option in some use cases, right? If you have a limited set of clients and you're okay with them all having to sign in again, or it's a really serious breach and you just want to like stop the bleeding, then rotate the keys. And then when those when the clients, or sorry, when the consumers, when like the JWT API tries to validate that JWT, it'll be invalid automatically because there'll be no key for it. A better, kind of slightly more elegant solution is what we call the time window solution. And so in this particular case, just like you have a webhook that fires for user deletes, you have a webhook that fires for logouts, which we call a refresh token revocation event. And then basically the JWT API keeps track, like basically a hash map or a hash in memory or in Redis or wherever of the tokens that belong to, or sorry, of the users who have revoked their tokens. So again, this is walking that balance line because you're basically pushing more state into the JWT API to deal with this. And so, how it might work in practice is right now, let's assume it's 1:12:47 on December 9th, and we are creating JWTs with a 30-minute expiration time. So if we create a JWT right now, it would expire at 1:42:47. That means that if our issue is we want to make sure that all JWTs are invalid, all JWTs created before right now are invalid because the user is logged out, then we know that a JWT created 1 second ago would expire at 1:42:46. That means that in the JWT API, we can know that any JWT that was created before 1:42:46 is now invalid because at 1:42:47, the user logged out. So, 1:12:47, the user logged out, that we add that 30 minutes and we can know that those JWTs are invalid. So basically the idea is we're just taking care of this red area, which is the 30-minute length of time in which a JWT would normally be valid, but we are pushing some state to the APIs to know that, okay, the sign event happened now. That means that anything that was created in this blue area, any JWTs that were created in this blue area would expire somewhere in this red area and are no longer valid JWTs. So does that answer your question? I'm sorry, I don't recall who asked that, but they were talking about, yeah.
It was Erhan.
Yeah, Erhan. Does that answer your question? Oh,
I have a question.
Sure.
So does that mean that this is the way that you would deal with invalidating the JWTs, would be to just keep track of the time? It seems kind of manual,
Sure. So you can definitely write libraries to deal with that. I think you need to think about what the security profile is, what the risk is of a JWT. Because the other option is you can make JWTs really small, or the timeline really small, right? You could make a JWT last for 30 seconds, and then your risk profile is not 30 minutes, it's 30 seconds.
Right.
But, that's the trade-off for not having to deal with the user API. I mean, there is a standard out there. I think it's 7009 that lets you revoke JWTs. But again, then you're back to the opaque token where you have to talk to the user API to find out, is this token valid?
Yeah, I guess it's manual, but it's also very simple and straightforward.
Yep.
Thank you.
Yeah, great. Yeah, and I'm not aware of any Ruby implementations of this. We've done a Java implementation, and I think we have JavaScript implementation, but it would not be hard to do a Ruby implementation, right? I mean, it's a hash map, and you just need to like do the math right. So cool. Any other questions right now? Cool. Well, I'm gonna share some code real quick. Oh, and I see some questions in the chat. Oh, good. Okay, great. Nothing for me.
Yeah, I didn't think there were questions as much as some comments in the chat. Sorry.
Cool. No worries. Great. Okay. Awesome. So this this repository is available. I'll put it in it's in the presentation. So if you want to download this and play around with it, it's just an open source repository I put together. And I have built explanations of JWTs, or not, sorry, sample code for kind of a bunch of different algorithms, but I'm only going to show you two today. So this is just a simple HMAC algorithm. So here we have our secret here, which this is a horrible secret. Please don't use this secret for real. And lines 3 to 19 are kind of the user API, the thing that's generating the JWT. And then the lines 21 on are the consumer of the JWT, right, that are decoding it. And so I can add, you know, other keys, premium, user, false, and I can add whatever I want in here, right? And I am having this expire 5 minutes from now. So if I go Ruby build, you can see that this is the JWT that was created. It's got the 3 components, and then when it's been decoded, it's just a hash that I can use, right? So that is all there. The next one is a little better. Same symmetric algorithm. If you have the issuer as fusionauth.io, and in the ToDo API, we actually check the issuer. And this is just done, again, this library provides some helper methods to do that. We can verify the issuer, we can verify the audience. And if we just run this, HMAC does great. If someone comes in and gets our key somehow, but neglects to change the issuer, we're going to blow up, right? Because the issuer doesn't match what we expected.
Did they neglect to change the issuer, or they changed the issuer maliciously?
Yeah, it could be either way, right? I mean, this is a defense in depth thing, right? Because in order to sign this in such a way that like you'd accept it, they need to have your key somehow too, right? Which obviously, if they have your key, where'd they get it? Did they get it because someone checked into GitHub, or did they get it because they're on your server and they're tweaking, you know, settings, right? If they're tweaking settings, there's you have bigger problems, but yeah. All right, cool. And as I mentioned, you know, well, actually, you know, I'll show you the RSA one real quick too, since we have. And this, obviously, you would typically not be generating your RSA key every time you're signing a JWT, but you would get it from somewhere else. But it's very similar, same kind of thing. So the one thing that is important, and this is something that libraries will give you, there was actually an attack against JWTs. I don't remember when it happened, but I read about it, where they were being signed with one algorithm, but the algorithm that was passed in the metadata was a different algorithm, and that caused a different kind of verification to happen. And so JWTs that I think issue. So you also want to check to make sure the algorithm that is being used to decode it is the same as the algorithm that was used to sign it. that concludes the code section. Unless anyone wants to see the code, or sorry, anyone has any questions about the code. Getting to the end, so.
No question. I was going to say, if you just run like a base 64 decode on a JWT to show people.
Sure. Yeah, let me do that real quick. So, let me stop sharing and share. Where'd you go? There it is. Share screen. So I'm gonna need JWT file. This is the JWT that I created previously, and so it's been a while since I've used base 64 on the command line. So you can see that the header is just base 64 encoded, and let's do the payload real quick.
I think you missed the. Oh no, you got the E. Cool.
Whoa.
You missed the E. The first.
Oh, did I? Excellent. Thank you.
Cool.
There we are. So there you are. So again, and so anybody who gets hold of your JWTs can do the same thing. Not hard to do on the command line online. So don't, and that's why we favor actually GUIDs as opposed to numeric IDs for our identifiers, because you know, if you have an identifier of 1, 2, 3, people might wonder, if they're looking at it, a malicious client might say, I wonder what 1, 2, 2, you know, there's 123 users at least, right? So yeah.
I work with someone who will literally, anytime they see an integer ID, they will go and they will scroll and they will try to get all the info. It's just like natural curiosity for them.
Sure. Yeah. All right, so we kind of went through the code. So real quick about, you know, we didn't talk a lot about Rails or Ruby in this, and you know, not going to dive too deep into that because the focus is really on JWTs. But if you're bringing JWTs into Rails, lots of times you are doing it as a consumer, right? Where you're like building an API and somebody else is responsible for creating it. But if you are actually generating them, again, use the library. I use the JWT gem as you saw. If you're kind of doing authorization with them, I've built out a before filter that went into an action controller, or is it before action? I don't remember what it's called, but it's something that executes right before any request is processed, and then it just examines that JWT. And I don't think it's in this presentation, but I can share that blog post if you want. There's also device integration, and I have not done much with this. And then finally for APIs, this knock gem was recommended to me by a friend. And that is a really nice kind of tightly integrated with JWTs API authentication layer. But again, I don't have personal experience with that. Quick tools and articles. Here are all, the second bullet point is the repo with my Ruby examples. This JWT Debugger is just one of many, many online debuggers that you can paste a JWT into, and it will give you kind of a 3,000 word essay I wrote on how you should build a secure JWT. And from the perspective, from the perspective of the builder of the JWT, the consumer of the JWT, the client, what a client should do, and then also of the consumer. And that's it. So I'd like to say thank you all for listening to me talk about JSON Web Tokens and asking great questions. And I'm happy to take any other questions, or if you want to talk to me about Fusion Auth or JWTs in the future, there's my contact info.
Were sub and what was it, audience, are those part of the UFC?
The sub and odd are standardized.
RFC,
things.
sorry.
Yep. There's another couple of them. Like you can actually, if you want, and this actually might be interesting to you all, you can actually set a JWT to be valid for some point in the future. So you can say it's not valid before this time, and it's not valid after this time. So if you wanted to, grant someone access just for a certain period of time, you could do the same thing. But yeah, 7519, you can check it out. I think there's like 8 or 10 standardized claims.
Cool. Are
Cool.
there any other questions or comments for Dan at this moment? See some nodding now. Okay, well,
Cool.
Thank you.
Dan. Thank you.
Thank you for having me. I really appreciate it. All right. Well, I'm going to go get my milk.